Hello everyone, I'm Ramanandan Krishnamurthy and I'm very excited to welcome you to this past summit session along with my colleagues and co-presenters in today's session, Arnaud, Comet and Rodrigo Souza. In this session, we will cover the features of Azure Synapse Link for Cosmos DB and how it helps you build self-service analytics and BI solutions with great performance, cost effectiveness and low operational complexity at scale. We have a power-packed session planned for you today. We'll start by providing an overview of Synapse Link for Cosmos DB. We'll walk you through some sample industry use cases and then dive into the meat of how this all works under the hood. We prepared some cool demos for you to see Synapse Link for Cosmos DB in action. How easy it is to configure and start analyzing data in Cosmos DB, as well as how you can build end-to-end BI workflows with the rich ecosystem of integrations in Synapse Analytics. So let's dive right in. As you all know, Cosmos DB is Azure's fully managed NoSQL database offering for modern app development. The reasons why customers have chosen Cosmos DB to back their mission-critical platforms in this digital transformation journey include providing industry-leading SLA-backed latency and availability guarantees, elastic scalability of storage and throughput, turnkey global distribution, and adopting an open-source API strategy, among other reasons. While app development is only one half of the story, we've seen from working with our customers that they almost always want to generate rich insights out of the data that their applications store. For instance, wanting to implement fraud detection over live order transaction data in retail, or anomaly detection over IoT sensor data in the oil and gas sector. Across industry verticals, customers are adopting a data-driven culture. At the core of this culture is the need to deliver analytics over real-time operational data at scale to transform existing business processes and stay ahead of the curve. Before Synapse Link, there existed primarily two options to achieve real-time analytics over Cosmos DB data. First, by running analytics directly on Cosmos DB along with the transactional workloads. While you could try to isolate the analytics workloads by running them on secondary replicas, the performance of typical analytical queries degrades as the volume of operational data increases and can be very resource intensive. The other option is to ensure there is no performance impact to OLTP workloads has been one where data engineers create and operationalize pipelines to periodically move data from Cosmos DB to a data lake. These pipelines must be then monitored and managed through their lifetime. Further, once the data lands in the data lake, data engineers have to continuously ensure that the data is in the right optimized columnar format for their analytical workloads as the data evolves upstream. It is only after this that the data can then be transformed, enriched, and served in analytical workloads. Thus, the analytical workloads are not running against the latest state of the operational data, leading to delayed insights. And this is where the power of Azure Synapse Link for Cosmos DB comes in. As a cloud-native HTAP capability that allows you to now run analytics over operational data in Cosmos DB in near real time with no ETL to manage and no performance impact on your transactional workloads, Azure Synapse Link finally breaks down the barrier that has long existed between OLTP and OLAP systems. So what's the magic powering Synapse Link? So far, prior to Synapse Link, your operational data in Cosmos DB is internally stored in a row-oriented transactional store. This store is optimized for transactional reads, writes, and operational queries. Now with Synapse Link, we've added a fully managed native analytical store within Cosmos DB container. The analytical store is a fully isolated columnar store optimized for typical analytical queries over large volumes of data. Any new inserts, updates, deletes to the operational data are automatically synced from the transactional store to the analytical store in near real time within a couple of minutes. This auto-sync capability does not consume RUs provisioned for your transactional workloads. Now with Synapse Link, you can connect Cosmos DB Analytical Store with Synapse Analytics workspaces with a single click, which then allows you to interchangeably query Cosmos DB data using Spark and SQL runtimes with no RU impact. This enables you to build machine learning pipelines, BI dashboards, and run big data analytics in near real time on your operational data. There are several industry use cases that can leverage this cloud-native HTAP capability for near real-time analytics over operational data. Here are 3 common use cases for Synapse Link for Cosmos DB. Manufacturers are onboarding to cloud-native technologies to break out of constraints of legacy ERP and supply chain management systems. With supply chains generating increasing volumes of operational data every minute, manufacturers need an operational database that can scale to handle the data volumes, as well as an analytical platform to get to a level of near real-time contextual intelligence to stay ahead of the curve. This architecture shows the power of leveraging Cosmos DB as the cloud-native operational database and Synapse Link to power supply chain analytics, forecasting, and reporting. First, I would like to draw your attention to the component of preparing and training predictive pipelines. Synapse Link enables data engineers and data scientists to build robust predictive pipelines. You can query operational data from Cosmos DB Analytical Store by leveraging the native integration with Spark pools in Synapse Analytics interactively or via scheduled jobs without complex data engineering. You can build machine learning models with Spark ML algorithms and Azure Machine Learning integration in Synapse Analytics. Finally, you can write back the results after model inference into Cosmos DB for near real-time scoring as well. Next, I would like to draw your attention to the component of operational reporting. Synapse Link for Cosmos DB enables rich business intelligence and reporting scenarios. You can query operational data from Cosmos DB by using this native integration with Synapse SQL Serverless and the full expressiveness of T-SQL language. You can model and build auto-refreshing BI dashboards over Cosmos DB through Synapse SQL Serverless support for familiar BI tools like Power BI, Azure Analysis Service, amongst many others as well. Next, retailers today must build secure and scalable e-commerce solutions that engage customers through customized product and offers and secure transaction processing with fraud detection. Cosmos DB, along with the latest Synapse Link capability, allows retailers to generate personalized recommendations for customers in real time using low latency and tunable consistency settings for immediate insights as shown in this architecture. You can leverage Synapse Spark to read data from Cosmos DB Analytical Store without performance impact to train ML models that can then be deployed to the application layer for online scoring and real-time personalization. Next, industrial IoT innovations have drastically reduced downtimes of machinery and increased overall efficiency across many industry verticals. One of such innovations is predictive maintenance analytics for machinery at the edge of the cloud. Here is an architecture leveraging the cloud-native HTAP capabilities of Synapse Link for Cosmos DB in IoT predictive maintenance use cases. The historical operational data from IoT device sensors could be used to train predictive models such as anomaly detectors. These anomaly detectors are then deployed back to the edge for real-time monitoring. Such a virtuous loop allows for continuous retraining of these predictive models. With the growth of digital twin initiatives, companies are collecting vast amounts of operational data for large number of sensors to build a digital copy of each machine. This data then powers business intelligence needs to understand trends over historical data in addition to real-time applications which are built over the hot data. Having seen some of the examples of the power of Synapse Link applied to real-world use cases, let's peel the onion a little more now. First, let's start with the Cosmos DB analytical store. As I had mentioned earlier, the analytical store is a fully isolated columnar store optimized for typical analytical queries over large volumes of data. Autosync refers to the fully managed capability of Azure Cosmos DB, where the inserts, updates, deletes to operational data are automatically synced from the transactional store to the analytical store in near real time. Autosync latency is usually within 2 minutes. The analytical store is optimized to provide scalability and elasticity out of the box. The storage technology is self-optimizing in nature. Thus, autosync happens in near real time regardless of the transactional traffic throughput, whether it is 1000 operations per second or 1 million operations per second, and the volume of data as well. One of the value differentiating features of analytical store is the promise of decoupled performance for analytical workloads from the transactional workloads. Fully isolated nature of analytical store guarantees no impact on the RUs provisioned on Cosmos DB for transactional workload needs, and the analytical store does not need separate RUs to be allocated. Pricing for analytical store is decoupled from the transactional store, and we'll cover that shortly. It is also important to note here that apart from the user's analytical workloads themselves, autosync also guarantees no impact to the RUs provisioned on Cosmos DB, which is impossible to achieve if you have to build and manage ETL pipelines yourself over Cosmos DB. One of the other problems we've solved out of the box for you is automatic schema inference. Cosmos DB transactional store is schema agnostic in nature, and this allows you to iterate on your transactional applications without having to deal with schema or index management. In contrast to this, we have built Cosmos DB analytical store to be schematized in nature to optimize for analytical query performance. To bridge this difference here, we have designed the autosync capability such that Cosmos DB automatically manages the schema inference over the latest updates from the transactional store when replicating into the analytical store. It also manages the schema representation in the analytical store out of the box, which includes handling nested data types. As your schema evolves and new properties are added over time, the analytical store automatically provides a unionized schema across all the historical schemas in the transactional store. With Synapse Link, you can connect your Cosmos DB database with a single click to a Synapse Analytics workspace. You can then query the data from Cosmos DB analytical store seamlessly and interoperably using SQL Serverless and Spark runtimes in Synapse Analytics without having to manage any separate connectors or data transformations. If you have a globally distributed Cosmos DB account, after you enable analytical store for a container, it will also be available in all of the regions of where that Cosmos DB database account is replicated. You can run analytical queries effectively against the nearest regional copy of your data in Cosmos DB with high availability and disaster recovery taken care out of the box by us. Here are some important settings related to Cosmos DB analytical store to note. The analytical store is not enabled by default when a new Cosmos DB container is created after Synapse Link is enabled on the database account. It must be explicitly turned on for a container, and the analytical time-to-live configuration must be set up. More on analytical time-to-live in a bit. Today, you can enable analytical store when creating a new Cosmos DB container either in an existing or new Cosmos DB database account. Support for ability to enable analytical store on existing Cosmos DB containers is coming soon. Once you create a Cosmos DB container with analytical store enabled, autosync kicks in without you having to set up anything more in all the regions where the Cosmos DB database account is replicated. Today, Synapse Link is supported for SQL and Cosmos DB API for MongoDB. Analytical TTL is one of the important knobs exposed on the analytical store and indicates how long data should be retained in the analytical store of a Cosmos DB container. If analytical store is enabled, data is always replicated from the transactional store to the analytical store, irrespective of the transactional TTL configuration. To control the lifecycle of this data in the analytical store, you can choose the corresponding value of the analytical TTL property on a container. If the value is set to 0, missing or null, the analytical store is disabled and no data is replicated from the transactional store to analytical store. If the value is set to -1, the analytical store retains all historical data, irrespective of the retention of the data in the transactional store. This setting indicates that the analytical store has infinite retention of your operational data. If the value is set to some positive number n, items will expire from the analytical store n seconds after their last modified time in the transactional store. This setting can be leveraged if you want to retain your operational data for a limited period of time in the analytical store. After the analytical store is enabled with an analytical TTL value, it can also be updated to a different valid value later. Data tiering refers to the separation of data between storage infrastructures optimized for different scenarios, thereby improving the overall performance and cost effectiveness of the end-to-end data stack. After the analytical store is enabled, based on the data retention needs of the transactional workloads, you can configure the transactional store time-to-live property to have records automatically deleted from the transactional store after a certain time period. Similarly, the analytical store time-to-live allows you to manage the life cycle of data retained in the analytical store independent from the transactional store. By enabling analytical store and configuring time-to-live properties as shown, you can seamlessly tier and define the data retention period for the two stores independently. We've also announced public preview of support for Azure Cosmos DB API for MongoDB in Synapse Link, along with the core SQL API of Cosmos DB, which is already in public preview. Synapse Link now provides a cloud-native HTAP capability for customers who have chosen to build their application stack on MongoDB in the cloud by choosing the Cosmos DB API for MongoDB. The general principle of Synapse Link applies as is for the MongoDB API as well. Users can run Spark as well as T-SQL queries against the data in Mongo collections with no impact to OLTP workloads and no ETL. Further, we have made an additional investment in how we manage the schema of the analytical store during the fully managed autosync functionality, especially for highly polymorphic NoSQL schemas, which we allow in Cosmos DB, being a schema-agnostic NoSQL system. To provide an optimized storage representation for analytical workloads, Cosmos DB creates a tabular schematized representation of the data in the analytical store, as I mentioned earlier, even when the data in the transactional store is non-schematized. This poses two unique constraints. What if the same property contains values of differing data types across items in the transactional store? For instance, in this example, purchase date property contains values of both string and integer data types. Similarly, what if properties of array type contain values of different data types? For instance, product vector property in this example contains values of integer, double, and string data types. Typically, this adds a lot of overhead in ETL scripts to account for such schema variance if you were to manage OLTP and OLAP systems independently. Luckily, with the fully managed autosync functionality of Synapse Link, this disambiguation is automatically performed, and as shown here, the schema variance is clearly disambiguated by extending property names by the data types in the analytical store, such that users can choose to query the appropriate columns based on their needs at runtime without any loss of data. This full fidelity schema representation is the default experience when Synapse Link is enabled for MongoDB accounts. Finally, Analytical Store follows a consumption-based pricing model where you are charged for 1. Consumed storage, that is the volume of the data retained in the analytical store every month, including historical data as defined by the Analytical Time-To-Live. The unit cost of 1 GB of consumed analytical store storage is 2 cents per month, which is an order of magnitude cheaper than that of the transactional store. 2. Analytical write operations, which encompasses the cost of the fully managed synchronization of operational data updates to the analytical store from the transactional store, aka autosync. The unit cost of 10,000 such analytical store write operations is 5 cents. 3. Analytical read operations, which encompasses the read operations performed against the analytical store from Synapse Spark and SQL Serverless runtimes. The unit cost of 10,000 such read operations is 5.5 cents. It is important to note that the billing model of Synapse Link includes the costs incurred by using the Cosmos DB analytical store that we have discussed so far, as well as the cost of the Synapse Analytics compute runtimes. With that, I would like to pass on the mic to Arnaud to share more details on the Synapse Analytics runtimes and how they integrate with Cosmos DB Analytical Store. Over to you, Arnaud.
Thank you, Ram. Now let me show you how this awesome work and architecture works with Synapse Analytics. So first of all, let me present to you what Azure Synapse Analytics is. You might not be familiar, but if you are familiar with Synapse, it's likely that you have seen this picture. Let me tell you what Azure Synapse Analytics is. Azure Synapse Analytics brings big data and data warehouse capabilities together, and will continue to bring additional capabilities in the future into Synapse. Those capabilities are integrated through a platform capability that have 4 pillars: the management, something that enables collaboration, CI/CD, chargeback, provisioning of pool, monitoring, when you think about debugging, alerting, and actions over your pipeline, over your job, Spark job or SQL query, security around network security, access to data and artifact, and manage VNet. And one important one as well is metadata, metastore. This is going to provide interoperability across SQL and Spark. So you create one table once, this table is honored across SQL and Spark, both in terms of metadata, but as well access. And one thing I wanted to mention, the data integration, I consider that almost as part of the platform. We took a lot of concepts from ADF and put that underneath into the platform to create pipelines, copy activities, and connect to the rest of Azure. This is what Azure Synapse Analytics enables. It enables you to create your data platform and provide BI, AI, and continuous intelligence over it. SQL and Spark as well are elastic. SQL can be consumed in a serverless fashion. We used to call it SQL on demand, now it's SQL serverless, and you have SQL pool, which provides you performance, predictability in performance, predictability in cost. You can as well pause or scale or resume this SQL pool. Last but not least is Spark. Spark is a great platform as well on its own to provide AI, to provide data engineering capabilities over in Synapse. So I wanted to show you this, and of course we have the experience, what we call Synapse Analytics Studio. And we are going to show you demos, so you will be able to see what the studio is. But it's a truly important element of Synapse. All of them we can as well connect as connected services, a bunch of different sources. That's why we enable BI, AI, and continuous intelligence. It's not just with Synapse, it's with the rest of Microsoft assets. From the data lake, from some database with like Synapse Link for Cosmos DB, Power BI, or AML. All of those capabilities can be integrated into Synapse. Let me pause it and go over the next element. How now in this awesome platform can I connect my Azure Synapse Link for Cosmos DB? It's very simple. It's a 3-step thing. First you connect, you are in your Data Object Explorer. You can click on plus, connect to external data. Next step is, based on your subscription, you can automatically, like it infers which account you have access in which database. Then you need, of course, to name your linked service. And finally, you can use run or Spark or SQL command with simple gesture. Whether now I have my container, I want to use the SQL script, I can set up 100 rows, there will be as well create view automatically, or I can use my Spark. New notebook, load to data frame, write data frame to containers, create Spark table, and I can do as well as stream data frame from a container or to a container, into a container. So that's very simple to connect actually in the Synapse. But you can do a bunch of things. Like I hinted you through the gesture. In a Spark, you can run ad hoc data exploration with Spark. You can run big data analytics for data preparation, curation in batch or streaming mode. And you can as well, with its deep integration with Azure Machine Learning, run ML, build and deploy model with it. What you can do as well directly through the gesture, I mentioned that you can create Spark table whenever you need frequent access. You can use data frame to read Cosmos DB data for batch or stream processing. You can write, and you can simply, because the way you are going to connect to it has no key, it's simple to use and secure. You call the link service, and over the link service, you say which container you want, and that's it. So that's the Spark side. On the SQL side, you can connect. It's very good for BI and ad hoc exploratory queries. We use Open Rosette, but to connect from a BI tool, you can connect with views today, and there will be tables. You can run analytical SQL queries in place, very quick, great performance. You can build dashboard with it. You can use a wide range of BI and ad hoc querying tool, not just Power BI. You can use as well AAS and other tools. And finally, it's great to build a logical data warehouse. SQL Serverless, Queries Data Lake Store, ADLS Gen 2, Azure Blob Storage, and as well Azure Cosmos DB. And we plan to expand that federated capabilities over the long run. This feature of Synapse Link is available in public preview since October 2020, so we are looking forward for you to try it and give us feedback. Now, this is my turn to pass the puck to Rodrigo, and we will see each other in the demo. I will show you to build the BI end-to-end demo from scratch. Thank you.
Thank you, Arnaud. Hello, everyone. My name is Rodrigo Souza, and I'm a Senior Program Manager with the Azure Cosmos DB team. Let's start with common Synapse Link scenarios. In this diagram, on the right, we can see Synapse SQL Serverless. It allows you to create BI dashboards using regular T-SQL queries and views. Also, it enables data exploration using regular common SQL clients like Management Studio or Synapse Workspaces. In the middle, we have another Synapse runtime, Apache Spark. It's also integrated with Azure Synapse Link. With Apache Spark, you can also do data exploration, but using languages like Spark SQL, Python, and Scala. Spark is also a great option for big data analytics. It enables you to do some data transformation and integration. And as an example, load the results into Synapse SQL Pool for data warehousing. Apache Spark is also deeply integrated with Azure Machine Learning, and you can build and deploy models using Azure Machine Learning SDK. But what if you have other operational databases on Azure? In this case, you can export this data into Azure Data Lake Store and use Synapse SQL Serverless to join all this data together. Or you can use Apache Spark for data integration, analytics, machine learning, and so on. So let's jump into our demos and see some of these capabilities in action. First, I'm going to show you how to enable Synapse Link and create analytical store enabled containers. Then we're going to ingest some data and explore with T-SQL using Synapse SQL Serverless. Then we're going to analyze some complex schemas and schema inference. So let me change to my browser. And we'll start with my brand new Cosmos DB database account. This account that I just created, to use Synapse Link, we need to enable Synapse Link at the database account level. So we have this button here to do it. But there is another option to do it, to enable Synapse Link. When you create a new container, at the end of the tab, you see that analytical store option isn't available. That's because Synapse Link is required to create analytical store containers. So again, you have a button to enable analytical store Synapse Link in the database account level. But we don't need to do it right now because I did it before in this other Cosmos DB database account. And if you go again to the Data Explorer, you see that we don't have the enable button anymore. So now if we create a new container, at the end of the tab, you'll see that analytical store is available. But again, we don't need to do it. I did it before. Let me hide the menu. So in the Synapse Link IoT demo database, I have two analytical store enabled containers. And let's see as an example the IoT data container. If we go to the scale and settings tab, we can see that analytical store is enabled. It's interesting to notice that we have a TTL, time to live, for your transactional data and another one for your analytical data. So they are independent, right? But let's use our, hold on a second. I also have this data generator, this IoT data generator. And it's a Python notebook. And here you see that you can also create an analytical store enabled container using our SDK. So most of our Cosmos DB SDKs already have this capability, and in the create container function, now we have this option to define what is the analytical store TTL of your container. But what -1 means? So we have these options for an analytical store TTL. When it's 0 or null, or not informed, because you can not inform, right, when you're creating a container, it won't be enabled. If you use -1, it means that the data will be retained infinitely. Any other number will be the actual TTL, the time to live of your data, in seconds, right? So if you check everything else in this notebook, let me initialize the Cosmos DB client. I need to create this function that creates some IoT random values. Also, we need to create the main function, and I'm gonna leave it running here at the end of this notebook. Oops. We're gonna execute this IoT data generator because we wanna check this data in analytical store using queries. So as you can see, we are creating data here live, loading data into our IoT container, right? Now let me jump to my Synapse workspace. And the first thing I want to show you here is that we, as I mentioned before, we have the two containers Analytical Store enable containers in my database account here. We have IoT data and device installation. So this is device installation is metadata about some of the devices we are creating for data here in this generator. So we have the device ID and some measures, RPMs and megawatts and so on. So I run this script before. So what I did, I created a view from the IoT data container. I created another view for the device installation container, but I changed the name a little bit, as you can see. Also, I have some data in my data lake. So I created some external files. So we'll be able to query and join this data together. I'm also creating a dimension for customers and installations. So now let's run some queries on these views and external tables we just created. The first one, I'm gonna show you how big it is. Let's see how many rows we have in the IoT data view. Almost 340,000. Now, on top of the same view, that in fact is an Analytical Store enabled container, right? Let's run this aggregation and count the number of measures above a specific value per device ID. So here's our report, let me see. And the third query I want to show you is a similar query, but now we are joining with a dimension we created that is a Parquet file in our data lake. It has information per city as well. So we are joining data that is stored in different places in the same query. In the next step of our demo, we'll talk about schema inference. And I'm using the device installation view. And in this view, you'll see that device installation. Let me open more room here, get some more room. The device installation column actually is a nested JSON document. Right? We have a couple of information here in an array. But what if I need to analyze this data individually? What if I need to explode this data structure into columns? So that's why we have this feature that will open that JSON information in columns. And this is very important for analytics and BI dashboards because now you can individually see the information, right, per column. And in the next step, in the last step of our demo, I'm going to show you also the data tab. And here in the, let me expand the menu. We have this concept of linked service, and I have some of them here, but I'm gonna create another one to show you how it works. So we're gonna add, I'm gonna connect to an external data, and this external data will be Azure Cosmos DB Analytical Store. So let's go here. I'm gonna call it, pass demo, and you can manually enter the information, but since we are here, we have our subscription, my database account, the database name is Synapse Link IoT Demo DB, and create our linked service to our analytical store through Synapse Link, right? So if I refresh here, you'll be able to see our past demo linked service. And when we expand this linked service, we'll be able to see our collections. And for our collections, what we can do, let's use the device installation again. We have some gestures here. So if you want to work with Spark, you're going to create a new notebook, and it will pre-build for you scripts to load data into a Spark data frame. You also it will create for you codes. It will create for you the data frame to container script, Spark table, and so on, right? But in this demo, we are working with SQL scripts. So we have this select top 100 script that is automatically generated for you. But it's not complete. As you can see, the key is not here. So let me grab my key from my database account. And I just need to replace my key here in the script. And as you can see, I'm not using, let me close the menu. And here, I'm not using a view. I'm querying the container, the analytical store container. And let me try to open to show you over here. And here's the results. We have again the device installation, this nested JSON file, but the idea here was to show you how easy it is to start using linked service and leverage these scripts that are automatically generated for us. So that's the end of our demo, and thank you very much. And Arnaud, back to you.
Thank you, Rodrigo. Now let me show you how to build an end-to-end BI demo with Synapse Link from scratch. In that scenario, we are going to be a manufacturing company, selling devices and in energy. And we want to make sure that those devices are operating efficiently, and we want to provide predictive maintenance in case we see that some parameters, some inputs shows us that those devices might not operate efficiently. So what we are going to do, we will create a database in SQL, Synapse SQL, and tables and views in that database. Those tables and views will point to Cosmos DB and as well data lake, because we want to enrich that data sets from Cosmos DB with some data in the lake. And Synapse SQL enables that. Then we'll run a query over that data set with SQL. But as we want everyone to have access, especially in the customer support center, we want to build a dashboard for these people to refresh and have direct access to data. That's where we'll use Power BI and model the database tables used together through the same kind of relationship we do in SQL in our SQL script. Then we'll create that dashboard. It will be very simple. I wanted as well to mention one aspect in the BI. You can use, I love that model because it's kind of smart caching, it's dual storage and as well directory. How to bring them together in the Power BI dashboard where you can use performance and caching and at the same time have other tables in our query mode. We'll do that over Synapse Link. So now let me switch into our Synapse environment. There is no database, you can see. Let me refresh. And we are going to create it. I connected my Cosmos DB container with a database with two containers. You can see they are Synapse Link HTAP enabled. And now I'm going to create first the database. So I'm creating a database called IoT data. So now let me get that database here. Oh. Yeah, you see it here. So we have a IoT database. We now want to create a view over that database, over Cosmos DB in SQL. So we are going to connect to the account called Rosas, like Rodrigo Souza, as well presenting. The database called Synapse Link IoT DB, the container IoT data. The region is optional. The system is able to pick a region for you if you don't put the region, but we recommend to put the region if you have multi-region, so you can pick the one you want to be queried. We have as well a key to enter. I won't show it, but you have a key. And here I show the schema, but you don't need to show the schema because we do schema inference now with SQL. So basically you can query the database, the container directly without specifying the schema. Here I want to cast as well the time, datetime, into datetime. So let me create the first view now. I'm going to create an overview. It's a complicated container. You have different elements, nested elements, and as well you have on top of nested array structure. And we want to flatten that out, and we use that on SQL servers to directly flatten that out and create a new view in Cosmos DB. So now if I go back, you can see I have my new database and I have two views, DB installer. Now let me go over creating over the lake. All these scripts seems impressive, but really what you have to do is very simple. You just have to go into your data lake. So I'm going into my data lake, I have past demo, and I have some data in customer. What you can do to pre-generate script, it's very simple. You can have that, create external table, and you can call the name you want in the IoT you want, the database you want, and call it foo. And what it does, it pre-generates script that you just have to run to get the table. So that's what I did. I just created this, and I need to do that over three folders. First, it's called the customer dim. I create a customer dim. The next one will be installation dim. I want all the installation data about my devices. And as well, the last one is about the product ID. So it's a typical way to create database. So you have now the three. It's already there. Now we have done step one, create database views and table. Let me show you some query directly on the cross data source. The first one is just that I want to know which devices over the period that we have data has gone over 4,400 rotation per minute. So then I get this, just simple as that. So it's just my Cosmos DB container that I'm querying through my SQL views. It's pure SQL. So I see two containers here, two devices here that had exceeded 2 times the value. So I want to know more where it is because I might want to send technicians. So what I do as the next table, I say, hey, now I want to learn how much or which city it is to understand where this happened. So it's in New York and Sao Paulo. So last, I will connect that to my customer dimension table to know which customer ID refers to which customer name. Let me see now. Okay, so we have Microsoft and Contoso, one in Sao Paulo, one in New York. Let's do that. Let's send someone. Now we have done this step. This is already step 2. Now let's go into a Power BI and let's connect into Power BI. So I'm going to connect to this database, to this endpoint. And I'm going to put my credential. We pass through AAD. I might have to use a code on my phone. No. So now we are connecting. Okay, so we have this IoT data. I want to get all the views and tables. Let's do that. And let's load them into my indirect query mode. So now it's going to evaluate, get the schema, detect the schema, all of that. And we are waiting for the model. Perfect, it's almost done. Perfect. So now we have this. We are going to create a model. Let me take, in a way, my fact table here is the IoT data. And I'm going to connect this, the IoT data with device ID here to my installation. Many to one. So many in IoT data, one in container. Let's keep that to move faster. I trust my link. Let me do that over this data too. You can see I have created the data that very similar. One is in the data lake, one is in a Cosmos DB container. And I'm going to do that here. Finally, we are going to create that here and here. I want my customer ID to be connected to my customer ID. It's many to one as well. Perfect. And I want my product ID and product ID to be connected to understand the product name. And that's it. That's it. Step 3, done. Now let's create a dashboard. So I want to know around the world where the data is. So let me create a map here. And you know that we had the city. We just need to put the location and the city to get that. So I'm going in my not IoT data. I need to go into my installation, for example, that one. And I put the city. And in the size, I will put from my IoT data, I want to put the measure value and I want to get as a size. I want to know the sum of IoT. Perfect. So now we know which, the size from London, Paris, Sydney, everywhere. So we have that. Now I want to filter and I want to have a measure type as well to be filtered because that's what I want to get is I want the rotation per minute, rotation speed. So this is what we are looking at. Let me go back to that. So we have that. I want as well now the value to be higher is greater than 4400. So now it's calculating and we know where it's higher or not. So this is this is nice to have that on a table, but let's say that now I want the same kind of table representation that we found with our query. So let's go for it. I'm going to create a new table. I'm going to create a new table here and put that here. Voilà. Same size. Let's do the same. Here we are going to have the measured value, the device ID, and I need to select it. device ID. I need to have a measure value. I want to have the customer, and I want the count actually. Let me put a count. I want to count as the same here. I want as well to put count because that was my filter. So we have here, we have this table. Let's continue with the country, the city, sorry. The city here, and let me put the customer name and go to my customer ID, and I get the name, and I'm going to show in the value count of customer. I'm going to put greater than 4,400. Up. I'm going to put more of the measure value here, add here, and I'm going to put this measure greater than 4,400. We want the value but the count, so we need a filter on the count. And here you go, Sao Paulo, New York. So it's super fast, super fast. And the same thing if I wanted here, the mistake I made is to have the count measure, so it's actually good. So this is super easy, and this is where we see. And we could add more. What I wanted to show you, it's quite fast. But the last thing, so we did number 4, create a dashboard. Last one is how to use the IoT data and how I want to cache it. So what I'm going to do, I want to cache, but to have a smart caching, I'm going to use dual. And I don't want all the other table here. I just want IoT data to be. So what it does, it will load the data that we had and push them into the cache. So I wanted to go. So we did number 1, 2, 3, 4. We'll see the performance over the Power BI. We can as well, what I wanted to show you, we can as well connect this report and build a dashboard directly from the link service. If you go here, you can connect to Power BI. Oh, that's done. You can connect to Power BI and typically connect to the workspace. Here I didn't send the workspace, but I have a bunch of workspace I can connect to, and then I can start embedding Power BI and building report out of the tables. It's really cool. And that's just the beginning of our integration. So now let me go back. So this is cache, and I just wanted to show you when things are cached, they can run much faster. And you know, it's a trade-off between real-time and cache. I like personally to have I like to have a direct query because Cosmos DB is getting, and Synapse Link, Synapse SQL are getting better and better and better. But let me show you on the size now how fast it is, how the city, how fast it is. All of that are generated super fast. And you know, the same report, if I build that report again, it will be super fast too. Let me go. Device ID, city, customer name. I'm putting that. Let me put measure value. Let me go over count, and you know, and you can see, and you know, I could put the city like I did, and the customer name like I did. So we are done. In just 15 minutes, we are done with our building from scratch, showing you how to create database tables views over Cosmos DB and query that with SQL, how to build model in Power BI and create a dashboard, Power BI dashboard, and how to use some of the optionalities that Power BI gives you between direct query mode and direct query import or dual storage, which is an hybrid. Thank you so much, and I hope you enjoy today at PASS, that you had fun, and if you have any question, please contact us. Please contact us here. Rodrigo Souza, Ram, or myself. Feel free to connect, and if you have any question about Synapse Link, you have Cosmos DB Synapse Link at Microsoft.com. Thank you so much, and talk to you soon. Bye.